Okay, we've got our Space Invaders game that we've built in Zig and Raylib, and it's looking pretty good, except our invaders aren't firing back, and that's not very fair. They feel like they deserve high-powered weaponry too. So what we're going to do is implement invader bullets or enemy bullets, and the player's going to have to watch out for those. So let's go ahead and create another struct up here at the top. And by the top, I've said this several times, I just mean above our main method, at the root scope, I should say. So we can create a const enemy bullet. That's going to be a struct, and it's going to have a position X, which is going to be a float 32, a position Y, which is going to be a float 32, a width, which is going to be a float 32, height, speed, and then finally active, which is going to be a Boolean. So one of the interesting things here is you might think, why not just use the bullets that we have? We could create another bullet pool, and then we could make these enemy bullets and maybe write in like an anonymous function that determines the collision detection, whether it should be against the player or the invaders, and reuse the bullet struct. And we totally could. And I think that's an approach that you definitely could take if you wanted to. But what I want to do is really customize the enemy bullet behavior. So while they sound like a player bullet and an enemy bullet's going to be pretty similar, they're going to be not as similar as you would expect. There will be some similarities, but they're not going to be as close as you might expect. And I think you'll see that it makes sense to do separate handling for these. So at this point, we're doing several things that we've done many, many times before in our Zig code already, which is setting up an init method, which is taking in some parameters to determine the initial value for some of these. It's returning at this, which I promised I would stop talking about. So if you don't know what that means at this point, check out any of the previous videos. I feel like I've mentioned it in every single one. Yeah, so we have our position X that we're setting, which is going to be position X. This needs to be dot because it's a field. This will be position Y. This is set to position Y. This is going to be width, which is set to width. 4K. Width. And then height, which is set to height. And then speed, which is set to 5.0. And then active, which is set to false. Okay. We need to add a couple more methods. We know that we want collision. We talked about it in the last video, but we need get rect to handle our collision. You could actually call this whatever you want, but for consistency's sake, we're just going to keep on calling it what we're calling it. And then I'm actually just going to grab this from one of the above examples, and then we'll just come in here and paste it right here. So we now have our getRect function. Uses the same field, so everything works really nice and easy, really copy and pastable in our case. Okay, so the bullets here have a speed of 5, where the player bullets have a speed of 10, so the players have a chance to actually dodge. We need to also set up a bullet pool and essentially a maximum amount of invader bullets. So what I'm going to do is create another const here called max enemy bullets. And it's going to be 20. And then down here, we can create another pool. So it'll be very, very similar. So it'll be enemy bullets, which is going to be of size max enemy bullets, enemy bullet, and we'll set it to undefined. And again, just like before, we're creating an array with a maximum size based off the value of max enemy bullets. The array holds enemy bullets, and we can set the default to undefined because we're going to go through and initialize all the values here in just a second. So let's do that. Let's iterate through those. So we have 4 enemy bullets. We get a pointer to a bullet, and we want to dereference that and say enemy bullet.init. Let me type that correctly. Enemy bullet.init. 0 bullet width, bullet height. We'll use the same constants for bullet width and bullet height, regardless of whether it's a player or an enemy. Okay, that gives us 20 enemy bullets, which there are many invaders, so we need more of these. And now we need to make them move and draw. So we have this part. So what we're going to do is actually, let's update the invaders so that they shoot randomly. Because if we think about how Space Invaders works, not all of the invaders shoot at the exact same time. It would be a very, very different game and a much more difficult game if all of the invaders shot at the same time. It would, yeah, be very, very different. Let's go to our enemy bullet. And we're going to add another method down here. And this will be our update method. So we'll say pub fun update. And what I want is a self. Remember, this takes in a pointer because we are updating and not just reading. And then we want the screen height, which is going to be an I32. And the return type can be void. So if self.active, we only want to do these checks if the bullet is actually active. Or rather these updates if the bullet is only active. So we have our position y, which is going to be self.speed. If the self.position y is greater than, and we need to do some type coercion using the as built in and the float32 type, and then the float from int built in, and we want the screen height. Then we can set it active to false. So essentially, do your drawing. If you're off screen, become inactive, so we can reuse the bullets for the bullet pool. We do need to add our draw method. This is actually going to be really, really similar to our other bullets. So I'm just going to hop up here and steal those from... Actually, this is fine. We can just steal the draw method from the invader. So I'm going to grab this. And then we'll come back down here to enemy bullet. Paste this. And we do have to update one thing, which is this is not alive. This is active. The rest of this matches pretty well. We don't want the bullets to be green, so we're actually going to make these yellow. So the invader bullets will be yellow. Okay, so these are going to be like player bullets, but they're moving down, adding to the Y value, and yellow color so you can distinguish them and not accidentally think you're catching your own bullet somehow. We need to add a shoot delay. So we're going to add some consts. Const enemy shoot delay is 60. And then const enemy shoot chance is 5. And we need to add another variable. Similarly to how we're doing the move timer, this is going to be enemy shoot timer. And it's going to be an I32, and it's going to be set to 0. So in our game loop, after we update our player bullets, we need to actually update our enemy bullets. So we'll come down here and we'll do a nice little for at enemy bullets. This gives us a pointer to a bullet. And then we'll do bullet.update, and then we need the screen height. So we'll just give it the screen height. Nice and easy. Now we need to do the enemy shoot timer stuff. So enemy shoot timer plus equals 1. If the enemy shoot timer is greater than or equal to enemy shoot delay, sorry, I forgot that was a constant, then enemy shoot timer is equal to 0, and then we need to actually do the shooting. So for invaders, give me that row. For the row, invader. If invader.alive, and raylib actually gives us this random value function that we can use. Seems like it would just be nice and easy to use since we already pull in raylib, so let's just do that. And then we essentially want to get that random value and see if it is less than the enemy shoot chance. And if it is, well, then we need to create some bullets. So while we're down here, we will iterate through the enemy bullets. Just going to give you a bullet. If that bullet is not active, then we want to update the position equal to the invader position. So invader.positionX plus invader.width divided by 2 minus the bullet width divided by 2. We talked about this kind of logic before. This is just essentially centering that bullet position on the source. So the source in this case being the invader. The bullet position Y is going to be equal to the invader dot position Y plus the invader height. So it starts at the bottom of the invader. Set the bullet active and then break. And then 1 and then 2. We can also break down here. Okay. So every 60 frames, we're going to loop through those invaders. Each living invader has a 5% chance to shoot. Get random value generates a random number between 0 and 100. So if it's less than 5%, or 5, I should say, then, we shoot. That's a 5% chance. We center the bullet on the invader and spawn it on the bottom edge. So now we need to draw them, right? Thankfully, this part's pretty easy. So let's go down to our draw logic, which is down here. For enemy bullets, bullet.draw. And I think that should be it. So let's give it a run. So zig build run. Looks like we have some errors. Value of type enemy bullet init struct ignored. So on 195, we have an ignored value. It's referenced by 280. This is actually that error message may not be super obvious, but what that is saying is that you're creating a struct and you're ignoring it. And the reason why is because I forgot the return. So let's give this another build. Zig build run. Let's see what we got. Not sure. I think my LSP may have had some issues there. So on 347, I have a issue because the value of type bool is ignored. So let's hop into 347. Oh, yeah, that just needs to be set to false. Okay, let's see them shoot. Maybe. Oh, oops. I said false. That needs to be true. Sorry. Let's give that another go. Yeah, there we go. Cool, perfect. So we've got invader bullets coming down, but they go right through us. Huh. Okay, that makes sense, right? We haven't implemented collision detection for these enemy bullets. We have our bullets with collision detection, but the enemy bullets have not been added. So how do we handle that? Well, so maybe we should think about what we want to happen, right? So when a bullet hits the player, I think that's game over. So let's build a game over screen. And what we will do is position the game over screen in such a way that when the player gets hit with a bullet, that takes over the screen. And that's what you get. You get a game over screen and an opportunity to retry. So what I'm going to do is create another variable here called game over. It's a Boolean. We're going to set it to false. I'm going to turn off Copilot again. And once we check those enemy bullets, so we have something down here that's like, so right here where we are iterating through our enemy bullets loop, we are updating those bullets in place. We can also add the check here. We can do another loop. This is kind of interesting because it's not necessarily drawing and it's not that initial update. It's more like bounce checking. So we have a couple different options, but I think I'm going to do it here. So we can check if the bullet is active, and then we can say if bullet.getRect intersects with player.getRect, then the bullet.active is false, and then game over is true. So if the enemy bullet hits that player, then game over. Now, at the start of our game loop, we actually want to change the way that we handle rendering. So we're all the way up here. I'm going to put this before our update. So essentially, if game over, then I want to draw some text using raylib. So I'm going to say draw text. The text I want is game over in all caps to make you feel extra bad. 270, 250-ish for the Y, 40 for the font. And then let's do raylib.color.red because that seems nice and ominous. We can do the final score. We should at least show them how well they did. So raylib.text format, final score, and that's %D. And it's worth mentioning Zig, if you're new to Zig, has its own formatting language, its own text formatting standards, and they're actually really, really nice. I am using the raylib stuff just because it's easy and in scope, and yeah, it really just easy and in scope. But there is really nice formatting built into Zig as well. Okay, so we have that score, and then we want to do something like draw text, and then the text that we want to draw is our score text. We want this to be a little lower than our game over. So maybe like 310, and then 30, a little smaller on the font size. Color white seems pretty good. Let's draw a little bit more text and say something like press enter to play again or escape to quit. And then like 180, 360, 20, and rl.color.green. You can tinker with these values so that they fit better for your needs. If you're coming from a web background, you will appreciate the beauty of Flexbox and Grid more and more as you start drawing arbitrary text to the screen. It is very hard to get things lined up the way that you would expect them to be unless you write your own like constraint system, essentially. Okay, that gives us some text. We need to make sure that if raylib.keypressed is keypressed, raylib.keyboardkey.enter, then game over is false. And we'll do reset game later. Cool, so we have something like this. So when game over, we're going to stop the normal game loop and show the game over screen. The continue statement is skipping the rest of the loop. And if we run it and get hit, we'll get game over. So we'll implement that reset functionality in module 9. And now we have stakes. So let's give it a shot and see if we can get hit by a bullet. Unfortunately, I'm a pro gamer, so the odds of me getting hit by a bullet are very thin. That is a joke, by the way. So yeah, this is what we have. Something game over. The default font actually looks like really nice and ominous in red, so that works out really well. You can see that it says press enter to play again or escape to quit. So if I press enter, it just keeps going because we're not resetting the game, but we'll do that in the future. Okay, we're actually like really close to having something really, really nice, but we're missing our shields. And this is going to be the arguably the most complex part at this point because we're putting everything together. We've got invaders, we've got bullets, we've got the shields. The shields are going to have health, they're going to deteriorate. There's so much going on. So this is going to be a big piece, and it's going to really carry us into the remainder of the game. And once we have the shields finished and the game over screen finished and maybe a victory screen, we'll be done. So we're actually really close. Anyways, we will implement that in the next module. So hopefully you found this one helpful, and stay tuned for defensive shields next.